going to explain you about the introduction part, which cover the background, scope and also objective of the experiment.
Moving on to the first part, background of industry. Packaged tubular reactor has been used in the water and wastewater treatment in order to remove the nitrogen and phosphorus from the effluent. In the present study by the International J Environment Rights Public Health, they demonstrated that the nitrogen and phosphorus were removed from the effluent using an energetic bioreactor packed with wood and iron, as we can see from the image here. Next, background of the experiment. In the experiment conducted, the resident time distribution (RTD) in the packed tubular reactor has been used to investigate on the resident time distribution in our tubular reactor. The resident time distribution can be used to compare its behavior of the two ideal reactor modes, the plug flow reactor or the continuous stir time reactor, or we call it CSTR. Next, we move on to the objective of the experiment. The objective of this experiment is to investigate the effect of liquid and gas feed rate on the mean resident time and degree intensity of liquid phase axial dispersion. There are two modes of operation used in this experiment, the co-current and also the counter-current. The input change has been introduced in this system in order to determine the resident time distribution. It is the step input and also the pulse input injection. Meanwhile, the objective of the report is to write the report on process industries of water and wastewater treatment that apply the concept of resident time distribution in packed bed reactor. The last point under the introduction part is the scope. In this scope, we are going to focus on the customer requirement, particularly in each type of customer, what will be the choice of the customer as well as the market demand. Throughout water and wastewater industry, we also highlight on the process plan description and also the process flow diagram. We focus on the equipment list used in waste and wastewater system as well as its unit description, and also we focus on the safety of the system and other consideration scope. Additionally, we also touch about the economic analysis and the overall conclusion of our experiment.
Assalamualaikum and hi, my name is Nur Nadia Nadira binti Mat Nazri. The part that I did in this no report are, the first one is the customer requirement, where I analyze the type of customers, the customer's choice and also the market demand. The next part is the economic analysis.
So, I will explain about the customer requirement in waste and wastewater industry. In this part, I will analyze the type of customers, customer's choice, and also market demand. Most probably, our types of customers are from manufacturers and suppliers of drinking water, pharmaceutical industry, mines and quarries industry, and also food industry. Wastewater treatment involving physical operations, chemical unit processes, and biochemical processes that are carried out in reactors. These are the principal types of reactors that can be used in this process, which is batch reactor, complete mixed reactor, plug flow reactor, mixed reactors in series, and also fluidized bed reactor. However, all the mentioned reactors should be able to fulfill these requirements, which is effective and energy-saving aeration, small footprint, easy construction and installation, high flexibility at fluctuating wastewater loads, fast installation, low maintenance, fully automated process control, and compatible with all classic processes. Market demand. Water is a global issue and reported as a crisis in the World Water Vision 2000. Raja Datuk Zaharatul report that the crisis is not about having too little water to satisfy our needs. It is a crisis of managing water so badly that billions of people and the environment suffer badly. My next part is economic analysis, which is I will analyze in terms of cost, utility, raw materials, and product. In terms of cost, it depends on the process treatment, service of the plant, and the source of the water. As reported by the Linus Corporation Ltd in Capital Cost Estimate for Malaysian Processing Plant, water and wastewater treatment plant costs about more than $5.5 million. In utility, utility is a term used by economists to describe the measurement of usefulness that a consumer obtains from any good. In our plant, water is treated and reused in order to save drinking water and reduce costs, and the less contaminated or low requirement water could be adjusted into a proper and cost-effective method, such as by using chlorine and other disinfectants. Raw materials. Our raw materials is water, which is come from two sources, which is groundwater and surface water. That water contains a varied range of organic and inorganic materials in solution or suspension. Chemicals may be added into the processes, such as disinfectants like chlorine, chloramine, or ozone, coagulants like aluminum sulfate, ferric chloride, and also various organic polymers. All of those chemicals are added in amount based on the capacity of the water treatment storage, and it significantly affects the cost of the process. And lastly, the product. Our product should be assessed before handling over to the customers to ensure the quality. This is where a process of validation and verification occur, and it should be carried out in another system so that the water can be safely used by others. All these processes also contribute in significant amount of investment.
Assalamualaikum and a very good day. My name is Dada Rosman and I'm in charge of the three sections in the report, which is the first, the process description of the chosen industry. We have chosen wastewater treatment. The second is the process flow diagram of the treatment, and the third one is what is the equipment involved in the treatment and what is the function of it in order to treat the wastewater from various sources. Thank you.
So, to make things simple, I'm going to explain both of the process description of the treatment and the function of the equipment in one go. So, now we have chosen one industry that features packed bed reactor prominently, which is the wastewater treatment process. There are 4 parts in this treatment, which is noted from the grey dotted lines of the upper section of the picture. So now first, the preliminary treatment, where most of the large foreign objects are removed mechanically. They have the bar screen and the grease and grit remover for this. The bar screen will just filter all the large elements from the water, and the grit and grease remover utilizes the gravitational force for the foreign particles to form grease balls and will be later removed by the scum remover. So second part is the primary treatment, where there's a large tank with a rotating stand called the primary clarifier is used to assist the smaller particle to undergo sedimentation process. Now the third one is the secondary treatment, which is also known as the biological treatment. It uses microorganisms to aerobically and anaerobically consume unwanted nutrient in the aeration tank. This tank has 2 sections. The one with the propeller will give oxygen for anaerobic reaction to take place, and the other one is the anaerobic chamber, which is for the anaerobic reaction to take place. And lastly, we have the tertiary treatment, or the chemical treatment. As the name suggested, this section includes the usage of chemical to treat the water, but before that, it has to be filtered to remove other fine particles, and this requires the usage of a packed bed of sand in a reactor, and it is called a sand filter. So next in the chlorination and dechlorination tank, chlorine will be added to kill microorganisms in the water. But however, it requires this chemical required to be moved to be removed from the water, as halides in chlorine, fluoride are unsafe for the humans. So thank you.
Hello everyone, my name is Nur Ahmad bin Rizal. So I'm in charge in doing the part which is highlighting the separation unit, and second is I will tell you more about the functions of the equipment itself. Bismillahirrahmanirrahim. So I will explain about the separation process unit and its function in process industry. In chemical processing, a packet bed is a hollow tube, pipe or other vessel that is filled with a packing material. The packing can be randomly filled with small objects like resting rings, or else it can be specifically designed structure packing. Packed beds may also contain catalyst particles or absorbents such as zeolite pellets, granular activated carbon, and etc. In industry, a packet column is a type of packet bed used to perform separation processes such as absorption, stripping, and distillation. A packet column is a pressure vessel that has a packet section. So basically, there are three substrate for flow possibilities in a packet bed, which are downward flow method, upward flow method, and recycling method. The recycling method is advantageous when a linear velocity of the substrate solution affects the reaction flow rate. This is because the recycling method allows the substrate solution to be passed through the column at a desired velocity. For industrial applications, upward flow is generally preferred over downward flow because it does not compress the beds in enzyme columns as downward flow does. When gas is produced during an enzyme reaction, upward flow is preferred. So this is the example of geometric diagram of the packet bed bioreactor. As we can see, for the first level is the reactor, second is the feed tank, third is the feed pump, fourth is the back wishing pump, fifth is a waste outlet, 6 A flow meter, 7 A pump, and lastly 8 is a effluent. For the filtration part in wastewater treatment, packet bed reactor are used for removal of chemicals or biological solids. These reactors have a higher performance compared to other conventional technologies. This packet bed provide rough surface textures or porous structures which enhance the attachment and retention of organisms. Packet bed reactor column usually attached with biofilm. Pump is required to make fluid move through the packet bed. In this case, sand was used, mixed with other substances to filter the fluid, and sand is cheaper and non-fragile but requires a significantly longer time for fluid to pass through. Thank you.
Hello everyone, my name is Ong Wei Ji. I will be explaining about the effect of the pulse input and the step inputs towards the system. So in my slide later, they will be having two modes of operation, which is the counter current and co-current. And what is the effect of the step input and the impulse input on them? And I will be analyzing them in terms of the mean residence time, the skewness, the variance, the concentrations, and the ET. Stay tuned. In this experiment, there are two types of input, which is the step change input and the pulse change input. In this experiment, we have to examine these two different inputs that will affect the mode of operation, which is the counter current mode and the co-current mode. What is counter current mode? Counter current mode is actually the liquid stream is flowing downwards from the top of the column, while the gas stream is flowing upwards from bottom of the column. As for the co-current mode, both the liquid and gas streams are flowing upwards from bottom of the column. And what is actually the difference of the step change input and the pulse change input? Step change input is the tracer concentration for a constant volumetric flow rate. It will be added constantly to the feed in condition that there's no feed is added before that. As for the pulse input, an amount of tracer was suddenly injected in one shot into the feed stream, which will be entering into the reactor in a short time. These are the effects of the response due to the step input. As you can see from these four graphs, the tracer concentration is added at t equals to 0. The concentration of the tracer will be increasing, then they kept at a constant level until the influence is indistinguishable from that in the feed. So the characteristics of the step response is they will be reaching a steady state mood at the end of the experiment. As for the pulse input, what you can see is the pattern of increasing until it reached a peak. Before that, it will show some decrement in value. Initially, the reading just showed only the conductivity of water to a sentence time. Since the conductivity of the sodium chloride is detected, the value started to increase. In turn, the increment in the graphic view is observed. After it achieved the maximum conductivity, the graph will be started to show a decrement in its value. These are the results that we get from the effect of the step input and the pulse input. We'll be analyzing the two modes of operations with mean residence time, variance, skewness, and dispersions. As you can see from the table, overall analyzing cold current has higher mean residence time than the constant current. It means that the particles that remain in the reactor has a longer time than that in counter current. This shows that cold current efficiency of the cold current is slightly lower than the counter current. Same goes to the variance and the skewness. The reading of these both category in cold current is higher than that in counter current. As for dispersion, we can see that in 4 different situations, they have high dispersion value in all conditions. These indicate that there is a significant deviations from plug flow. This may be because of the packing in the columns. Now, let's analyze the graph part. After we calculate the concentration versus time, we use the values to calculate the ET to time, and this is the outcome of it. As you can see from the graph, in counter current, it started to increase at t equals to 0 and become constant at t equals to 6 minutes. Due to some improper mixing with the reactants, the graph shows a negative effect. However, it shows that the counter has took less time to mix among the reactors than that in the cold current mode. In other way round means that the efficiency of mixing in cold current mode is higher than that in cold current mode. So in cold current mode, it reached a steady state at t equals to 6 minutes, while in counter current modes at 6 minutes. At the 6 minute, the graph shows a steady state value, while in the cold current mode at 7 minutes, the graph only shows the steady state mode, which means that the mixing of the cold and the counter current mode is faster than the mixing in cold current mode. And now let's analyze the pulse input. As you can see from the graph of ET to time for pulse change in counter current mode, the counter current will reach the maximum conductivity first as compared to the cold current. Technically, it explained like that, but unfortunately, due to some improper mixing with the reactants, the graph actually get abnormal result as we encounter some mixing issues. Although we can't compare with our readings, but theoretically, counter current mode has the higher efficiency than the cold current mode. Thank you.
For the conclusion, in a nutshell, this report can be divided into 2 parts. The first part is the highlight of water and wastewater treatment industries where packed bed reactor is widely used in the manufacturing the dirty water, treatment of pharmaceutical wastewater industry, and wastewater from metal mines as well as agricultural and food operation. There are increased demand of clean water that make use of packed bed reactor in the wastewater treatment industry is very essential. packed bed reactors are importantly used to remove the chemical or biological solid. The second part is based on the experiment data, where we obtain that in stepped input change, the mean residence time is higher than in the co-current than counter-current mode. In the pulsed input change, the mean residence time is also higher in co-current than counter-current mode.